Hello friends, this is the second part in chapter Aldehydes, Ketones and Carboxylic acids. In our previous session, we have studied about the nomenclature and introductory part of aldehydes and ketones. Today we shall study the methods of preparation of aldehydes and ketones. First we shall study the methods by which both aldehydes and ketones can be prepared. Means using these methods you can prepare aldehydes or ketones or both. So methods of preparation of aldehydes and ketones. The very first method is the one that you have studied in chapter alcohols, that is by oxidation of alcohols. We know oxidation refers to addition of oxygen. So if you add oxygen to alcohols, you will get either aldehydes or ketones. The type of alcohol that you choose to prepare decides what product you are likely to get. If you choose a primary alcohol, you will end up with an aldehyde, and if you choose a secondary alcohol, you will get a ketone. Now if you remember the oxidizing agents that can be used for oxidation, there are many, like acidified potassium dichromate, alkaline KMnO4, dilute nitric acid, etc. To be more precise, for oxidation of alcohols, remember acidified potassium dichromate as the best oxidizing agent. So if you choose a primary alcohol and if it is oxidized in the presence of acidified potassium dichromate, which is a very good oxidizing agent, then you should get aldehyde or ketone. How is that formed? You eliminate this water part. So when water is lost, what remains behind is R, C, H and this O. Aldehyde is obtained as a result of oxidation. So oxidation of primary alcohols gives you aldehydes. Similarly, if you have a secondary alcohol, its oxidation using the same oxidizing agent, that is acidified potassium dichromate, it will give you R, C, double bond O, R. How is this happening? You eliminate water from here plus H2O. Primary alcohol's oxidation gives you aldehyde, secondary alcohol's oxidation gives you ketones. In the exam they can ask you either the general equation or they will simply give you like what product is obtained when ethanol is oxidized. Can you try this on your own? So eliminate water from this part. So the final product will be acetaldehyde. Acetaldehyde is obtained or ethanol is obtained. Similarly, if isopropyl alcohol, which is a secondary alcohol, is oxidized, what product is obtained? Then you will get CH3, CO, CH3. You will get propanone or acetone as the product. So this becomes your first method of preparation, that is by oxidation of alcohols. Whenever alcohols are oxidized using acidified potassium dichromate as an oxidizing agent, you will get aldehydes or ketones. Always remember, oxidation of primary alcohols will give you aldehydes, oxidation of secondary alcohols will give you ketones. Now for the second method, by dehydrogenation of alcohols. This also you have studied in the chapter of alcohols in their chemical properties. What changes here? Nothing is added. Instead, copper or silver catalyst is used. and alcohols are heated at about 300 degrees Celsius. So what product is obtained? See, whenever alcohols are heated at a temperature of around 300 degrees Celsius at a temperature of around 300 degrees Celsius in the presence of catalyst like copper or silver, then it says dehydrogenation means remove hydrogen. So eliminate one hydrogen from here, one hydrogen from here. What is left? RCHO, aldehyde plus H2. Similarly, this will give you ethanol plus hydrogen. On the same lines, if a secondary alcohol is dehydrogenated, you will get, by loss of dehydrogenation, by loss of hydrogen, you will get ketone. Finally, for isopropyl alcohol, you will get acetone. So by the first method and by the second method, both you can prepare aldehydes and ketones. The only difference is, for oxidation you use acidified potassium dichromate. For dehydrogenation you use any catalyst like copper or silver, maintaining the temperature at 300 degrees Celsius. Remember, dehydrogenation of primary alcohols gives you aldehydes. Dehydrogenation of secondary alcohols gives you ketones. Then the third method. The third method is from hydrocarbons. From hydrocarbons. Hydrocarbons are those which contain carbon and hydrogen. Under this you have first method by ozonolysis of alkenes. By ozonolysis of alkenes. Ozonolysis, you know what hydrolysis is. Lysis refers to breaking. Ozonolysis means breaking of any given molecule using ozone as a reagent. Similarly, hydrolysis means breaking of a molecule using water as a reagent. For hydrolysis we use water as a medium. For ozonolysis you use ozone. Let us take one alkene, a general form of alkene. If this is an alkene and if it is reacting with ozone, then what happens? Now remember, ozone breaks the double bond in this way. Keep the atoms intact, do not disturb them. This part and this part remain, keep them as it is. Now break this double bond. I'll break one bond and I'll insert one oxygen from here. So how many oxygen are remaining? Two more. And how many bonds? One more bond. So that bond is now replaced by two oxygen atoms. This product is called ozonide. It is called ozonide. Whenever alkenes are reacted with ozone, they will give you ozonide. Now to get our desired product, you use zinc dust in presence of water. In other words, it is hydrolysis using zinc. In place of zinc dust, this ozonide breaks in this form. Therefore, the final product will be RCHO. After hydrolysis, you will have RCHO as one product, RCHO as another product. So, two molecules of aldehydes are obtained. You may ask, sir, what happened to this oxygen? It will go in the water medium as it is. It might react with zinc to give you zinc oxide as the product. That is not required. So, now whenever alkenes are reacted with ozone, they will give you corresponding ozonides whose hydrolysis using zinc dust will give you aldehydes, or it will give you ketones, or it will give you a mixture of both aldehydes and ketones. Try not to get confused. Whenever alkenes are ozonized, they will give you ozonide as the product. Further hydrolysis with zinc will give you either aldehyde or ketone or both aldehydes and ketones. To prove this point, let us see some more examples. If I take the simplest alkene, that is CH2 double bond CH2, which product is this? It is ethene. If it is reacted with ozone, what product is obtained? You keep the carbon and hydrogens intact. Instead of double bond, you insert 3 oxygen, break them in presence of zinc dust and water. So you will get HCHO, formaldehyde. Again HCHO. 2 moles of formaldehyde are obtained. This is when you take simpler alkenes. If you have a different alkene, say this example, CH3, 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 CH double bond CH2. If you take propene, what product is obtained? Ozonide remains same, except here it becomes double bond and here it is CH3. So after hydrolysis you will have CH3, CHO as one product. This won't be the main product. You will have CH3, CHO as one product, and the other product will be HCHO. HCHO. So depending on the nature of alkene that you choose, your products will be different. If you choose a simple alkene, a symmetrical alkene, you will have same products, same kind of aldehydes. If you choose unsymmetrical alkene, 2 different products are obtained. Both of them are aldehydes only. Let us see a different example now. Again a different alkene. This time I will use a branched alkene, CH3, CH3 double bond CH2. Instead of this, I can choose CH3 plus O3. What is this compound? It is 1, 2, 3, 4, 2-methyl butene. 2-methyl butene. Now if this compound is subjected to reaction with ozone, then what is obtained? I already said you, do not change any carbon atoms and hydrogen atoms, only the double bond should be broken. So keep all of them as it is, CH3, C, here also CH3 as it is. The other part, CH, single bond, CH3. Keep all of them as intact. Now here insert oxygen, here 2 oxygens. Now how do you break them? You break them in such a way that you get aldehydes and ketones. Then when it is hydrolyzed using zinc dust and water, what is obtained? Now notice, I will begin from here. CH3 dash CHO. It is an aldehyde. On the other side you have CH3 dash C, mele on the upside CH3. This side the bond broke, therefore double bond O. This is a ketone. So depending on the nature of alkene you choose, you will get different products. If you choose branched alkenes, you will get a ketone and an aldehyde, or both ketones also. Therefore whenever alkenes are subjected to ozonolysis followed by hydrolysis with zinc and water, you will get either aldehyde or ketone or a mixture of both aldehydes and ketones. This was by ozonolysis of alkenes. Under same hydrocarbons you have one more method wherein now you use alkynes. By hydration of alkynes. Choose the simplest alkyne, that is propyne. Okay, for this compound, you are supposed to add water. Hydration refers to addition of water. When water is added, you split water as HOH. HOH. Now add water to alkynes. Remember, for hydration you need some reagents. These are mercury sulfate in presence of sulfuric acid at a temperature of about 60 degrees Celsius. Under all these conditions, water can be added to alkynes. How is it added? One hydrogen of water is added to one carbon of alkyne. The remaining hydroxyl part is attached to the other carbon. So you will have CH2 because one hydrogen is added to the first carbon. Instead of triple bond, it will now become double bond. CH as it is and OH. If I have not told you, I will repeat once again. A carbon which contains double bond as well as oxygen as well as hydroxyl group attached to it is unstable. For this reason, it undergoes isomerization. It changes some of its atoms on its own, that is, it transfers this hydrogen here and the double bond between carbon and oxygen. Then what will happen? You will have CH3. Earlier it was CH2. One hydrogen is transferred here, CH3, single bond, C, double bond OH, or simply said CH3, CHO. It is acetaldehyde. It is acetaldehyde. So how do you represent this in statement form? When ethyne is hydrated, when water is added on ethyne in the presence of mercury sulfate and sulfuric acid at a temperature of 60 degrees Celsius, you will get enols. Enols. These enols undergo isomerization to give you aldehyde. Which aldehyde? Acetaldehyde. Let us see another example of propyne. CH3, C triple bond, CH plus water under same conditions. So how will you add? You transfer hydrogen to one carbon, the hydroxyl group to the other carbon, then CH3, single bond, CH, double bond, CH, OH. Now what happens? Again it undergoes isomerization. Why does it undergo isomerization? Because a single carbon cannot have double bond as well as hydroxyl group attached to it. Then what happens? Then you now remove hydrogen from here. You remove hydrogen from here, transfer it to the other carbon. Okay. You remove oxygen, transfer it to the middle carbon. CH3. This was single bond carbon. Now this carbon lost its hydrogen to the third carbon. Earlier there was one hydrogen, now it became two hydrogens. Understood? From here you transferred oxygen to the middle carbon, transfer it here. There was already one hydrogen here, so it now becomes CH3. You will get acetone or propanone as the product. Remember, in this reaction only ethyne will give you aldehyde. Rest of all the alkynes will give you ketones only. A specific reaction, and most prominently, most of the times asked in competitive exam, what is the hydration product of so and so alkyne? So remember, only ethyne is the alkyne which gives you aldehyde, and rest of all the alkynes will give you ketones. Understood? So till now we have studied three methods, out of which the first method was by oxidation of alcohols. Primary alcohols oxidation gives you aldehydes, secondary alcohols oxidation gives you ketones. Second method was by dehydrogenation of alcohols. Primary alcohols dehydrogenation gives you aldehydes, secondary alcohols dehydrogenation gives you ketones. What is the catalyst used? either copper or silver is the catalyst used. Then third method we have from hydrocarbons. Under that, first was by ozonolysis of alkenes. Any alkene upon ozonolysis followed by hydrolysis with zinc and water will give you either aldehyde or ketone or a mixture of both. Last method is by hydration of alkynes, under which only ethyne upon hydration will give you aldehyde, rest of all the alkynes will give you ketones. So these were the three methods by which you can prepare either aldehyde or ketones. Now let us see some reactions and some methods by which you can prepare either aldehyde or ketone but not both. So these are exclusive methods for preparing either aldehydes or ketones. So the second part is methods of preparation of aldehydes only. Means by these methods you cannot prepare ketones. Under that, the first method is by using or from acid chlorides or acyl chlorides, both are same. How is this done? The general formula of acid chloride is RCOCl. RCOCl. Whenever acid chlorides, its split form can be written as RCOCl. Okay. Whenever it is reduced, reduction means addition of hydrogen, reduced in the presence of catalyst like platinum or palladium in presence of barium sulfate. This is compulsory. Then how is the product obtained? You add one hydrogen here, the another hydrogen here. Then what product you will have? You will have RCHO, aldehyde plus HCl. Very simple method and very important method because it is a named reaction called as Rosenmund's reduction. What is the name? It is Rosenmund's reduction. What is Rosenmund's reduction? Whenever acid chlorides are reduced using hydrogen in the presence of platinum or palladium as a catalyst deposited over barium sulfate, aldehydes are formed. This reaction is called Rosenmund's reduction. This reaction is called Rosenmund's reduction and it is important for exams. For theory as well as other competitive exam, always remember named reactions are important. So it is one of the named reactions from aldehydes chapter. And I should tell you that there are many named reactions from this chapter than from the previous chapters like haloalkanes and haloarenes and alcohols, phenols and ethers. Compared to those two chapters, in this chapter, that is aldehydes, ketones and carboxylic acids, you have many named reactions. So you can expect many twisted questions, many multiple choice questions and many concept based questions, that is logic based questions. If so and so reactants are given, if they react with each other, what is the product obtained, or else they will give you reactants, the reagents as well as the products. You are to name the reaction, you are supposed to name the reaction, or else if they give you name of the reaction, you have to remember what reactant, what reagent and what product is obtained. Understood? So this is one important reaction. It is Rosenmund's reduction. The second reaction is from nitriles. Nitriles is the IUPAC name for cyanides. So how are cyanides written? RC triple bond N. It is nitrile. Whenever nitriles are reduced again using stannous chloride and HCl. In some books they prefer to write this as tin in HCl. Both ways are correct. Both ways are correct. So this HCl gives you hydrogens for reduction. How is this done? You break triple bond, add one hydrogen here, one hydrogen here. So what product is obtained? RCH. Instead of triple bond, now it becomes double bond NH. This product is called imine. is called imine. Whenever nitriles are reduced using stannous chloride in HCl, you get imines as product. How many hydrogens were used? 2. So write 2H. In some books, this reaction is slightly modified as this part remains same, this part remains same. Instead of this product, they will write RCH double bond NH dot HCl. Dot HCl. This means even after donating hydrogen atoms, this HCl remains attached to these imines. This product is called iminohydrochloride. Iminohydrochloride. For the reaction, what do you need? You need aldehyde. This is now hydrolyzed. How is it hydrolyzed? See, you use for hydrolysis water, no? So use one molecule of water, break here. After breaking, add oxygen here. How many hydrogens are remaining? 2 hydrogens. So RCHO is one product, aldehyde is our main required product, plus NH3, ammonia as a byproduct. If not, if iminohydrochloride is there, then you break again here, use oxygen on this side, 2 hydrogens on this side, then you will have aldehyde plus NH 1, 2, 3, 4, NH4Cl, ammonium chloride. Whether you write imine and ammonia, it is correct. If you are writing iminohydrochloride and then ammonium chloride, this method is also correct. Choose any one method, but do not get confused. If you are writing iminochloride and then you write this reaction, it becomes wrong. Or else if you are writing imines and then giving product as aldehyde plus ammonium chloride, it is wrong. So, how do you represent this in statement form? Whenever nitriles are reduced in presence of stannous chloride and HCl, imines are obtained whose hydrolysis in acid medium will give you aldehydes as product. Now this reaction was given by a scientist, Stephen. It is also a named reaction. Therefore, it is called Stephen's reduction. It is called Stephen's reduction. What is Stephen's reduction? It is a reaction where nitriles are reduced using stannous chloride and HCl to give imines, which are further hydrolyzed in acid medium to give you aldehydes. So both of these are named reactions. Let us see some other reactions by which aldehydes can be prepared. These reactions are also important. So the first reaction under the third method is from aromatic hydrocarbons. Under aromatic hydrocarbons, you have first method using chromyl chloride. You see, organic chemistry is more of a memory based concept. You need to remember everything, later on memorize, practice, only then it will remain permanently fixed into your brain. Otherwise, if you simply listen here and after which you do not follow up, you will not remember. It is a very volatile subject. We say chemistry is volatile, organic chemistry is much more volatile. So for that reason, whenever you are studying organic chemistry, make it a point that you practice a lot. Unless you practice, you are likely to forget the concepts. There are many reactions, all of which will require less reasoning but more mental reasoning. Now, using chromyl chloride formula is CrO2Cl2. This compound is called chromyl chloride. For this reaction, I will use toluene. How do you write toluene? Benzene with CH3. I will use toluene. From these methods, you can prepare only aromatic aldehydes. So whenever toluene is reacted with chromyl chloride. Whenever toluene is reacted with chromyl chloride in the presence of carbon disulfide as medium, an inert solvent, then you will have this product CHOCROHCl2 twice. Its hydrolysis in presence of water will give you benzaldehyde. You may ask, sir, how do I remember this? Memorize. There is no other alternative. Sir, what should I call this? You call it an adduct. An adduct is an addition product. Whenever chromyl chloride is reacted with toluene, an adduct is formed, or simply you say, if not adduct, you say a complex is formed. A complex is a bigger compound. A complex is formed whose hydrolysis will give you benzaldehyde. Most of the students, this complex looks difficult to remember. Better if I skip this reaction. Do not skip, because it is also a named reaction and an important reaction in the exam. It is called Etard's reaction. This reaction was given by Etard, therefore it is called Etard's reaction. How do you write in statement form? When toluene is reacted with chromyl chloride in the presence of carbon disulfide, a complex is obtained whose hydrolysis gives you benzaldehyde. This reaction is called Etard's reaction. Now, if this is clear, then second, B, using chromic oxide. Again same, use toluene plus chromic oxide is CrO3 in the presence of acetic anhydride. In the presence of acetic anhydride, you will get this part remains as it is. Here CHOCOCH3 OCOCH3 means these two acetyl groups will go and attach on toluene. This compound is called benzylidene diacetate, because two acetyl groups are attached, therefore benzylidene diacetate, whose hydrolysis gives you benzaldehyde. You need not worry about the byproducts in these reactions. Which reactions? From aromatic hydrocarbons, whichever reactions follow here, you need not remember the byproducts. Like in Etard's reaction, there was a complex in the middle step which was very bigger. You may ask, sir, what happened to the other byproduct? Forget them. If you write the main product, that is enough and it is much required. So in this reaction, toluene is reacted with chromic oxide and acetic anhydride to give you benzylidene diacetate, whose hydrolysis gives you benzaldehyde. There is no name for this reaction, so less important, not as important as the others like Etard reaction using chromic oxide. Then we have third reaction by side chain chlorination. For this, keep again toluene as the third method by side chain chlorination, followed by hydrolysis. So in this method, we react toluene with chlorine in the presence of sunlight and it gives you benzal chloride. Benzal chloride means a compound in which the toluene group is substituted by two chlorine atoms. Now again hydrolyze this, you will get benzaldehyde as the product. Then Fourth method, it is a named method by Gattermann-Koch reaction. In this method, you react simply benzene and not toluene with carbon monoxide and HCl in the presence of anhydrous AlCl3. Then you remember each benzene's carbon has one hydrogen attached. So this hydrogen is eliminated outside and this much part is attached here as benzaldehyde plus again HCl. Some of you might get confused. Sir, there is already one HCl. How did I get another HCl? So this entire part is HCOCl. From here you eliminate one H. This much part is attached to benzene and this H along with Cl goes as HCl. This reaction is called Gattermann-Koch reaction. When benzene reacts with carbon monoxide and HCl in the presence of anhydrous AlCl3, benzaldehyde is obtained and this reaction is called Gattermann-Koch reaction. Now we shall see methods of preparation of only ketones, because by these methods you cannot prepare aldehydes. Methods of preparation of ketones. The first method is by acid chlorides. In Rosenmund's reduction, that was the method for preparation of aldehydes, you used again same acid chlorides. There it was reduced using platinum or palladium in presence of barium sulfate. Here you use acid chloride, react it with dialkyl cadmium, then you will get ketones and cadmium chloride as product. This is one method, not so important. Now in the second method, there in the methods of preparation you had prepared by Stefan's reduction using nitriles. Here also use nitriles from nitriles, but the second reagent would be different. RCN. React this with a Grignard reagent in the presence of dry ether. Attach this R to the carbon part and the remaining part to nitrogen. Then R, C, one more R here, double bond, N, single bond, Mg, X. Because it is an addition product, it can be called an adduct. Now hydrolyze this in presence of acid, or simply write hydrolysis. How do you hydrolyze in order to get ketone? Break here, O, 2H here. So our required product is R, C, R, double bond O. Ketone is obtained. Now what about byproducts? This cannot go as it is, so again break here. Choose one more water molecule, keep OH here, H here. So you need to use hydrolysis twice. So NH3 plus MgOHX, hydroxy magnesium halide. In the second method of nitriles, react nitriles with Grignard reagent in presence of dry ether. An adduct is formed whose hydrolysis will give you ketone. Then third method is by Friedel-Crafts acylation. It is by Friedel-Crafts acylation. In this method, you react benzene, subject it to acetylation by using acetyl chloride in the presence of anhydrous AlCl3. You will get acetophenone and HCl. Here is H, this H and Cl will go, acetyl group will attach to benzene. Similarly, you can carry out benzoylation by reacting this with benzoyl chloride by reacting it with benzoyl chloride under same conditions anhydrous AlCl3. This time you will get benzophenone as product. You will get benzophenone as product. So by these three methods you can prepare ketones. So today we studied all the methods of preparation of both aldehydes and ketones, only exclusive methods for aldehydes and exclusive methods for ketones. In our further classes we shall study their properties. Thank you.